Greeting to doctor. Today I want to do my presentation, which is assignment 5, task 2, which is Beeq 1013, Introduction to Mathematical Economy. My name is Fang Yi. My matric number is 2x7579. I am a Group C student. So in this video, we will notice about how to use first and second derivative to find the concavity, marginal cost function, and maximum profit at each level of production. So let's look about the question. Question 1, A. Determine where the function fx equal to x cubed minus 6x squared plus 18x minus 15 is concave outwards and where it is concave downward. So look about the solution. First, differentiate using the power rule. So we can notice that the first derivative will become 3x squared minus 12x plus 18, and the second derivative will become 6x minus 12. Second, let the second derivative equal to 0, find all the value of x and the intervals. So 6x minus 12 equal to 0, we can notice that x will become 2. Third, test the interval to identify their concavity. So in the interval, we will put negative infinity and 2. In the test point, we can choose negative 1. And we can notice that the second derivative value will become negative 18, and the sign is negative, and the concavity for second derivative is less than 0 and it was downward. And for the intervals 2 and infinity, we can choose the 3 as our test points. We can notice that the second derivative of the value will become 6. The sign is positive, and the second derivative will more than 0. It was upwards. So as a conclusion, the function fx equal to x cubed minus 6x squared plus 18x minus 15 is concave downward on the interval, which is negative infinity and 2, and is concave outwards on the interval, which is 2 and infinity. So now, let's look about the second question, which is question 1b. Suppose that the cost function for a manufacturer is given by a cost function which is 0.00001 x cubed minus 0.003 x squared plus 5x plus 1000. Describe the behavior of the marginal cost function. In this question, we want to find the marginal cost function and describe the behavior of the marginal cost function, whether concave outwards or concave downwards. Prove your answer. So now, let's look about the solution. Want to find the marginal cost function, we will write down MC equal to dc divided by dx, which is the first derivative cost function, which is 0.00003x squared minus 0.006x plus 5. Why we want to use the first derivative? Because first derivative can measure the rate of change. So the solution for the B2, which is the behavior of the marginal cost function, we will write down the first derivative of the cost function, which is 0.00003 x squared minus 0.006x plus 5, to find out the second derivative cost function, which is 0.00006x minus 0.006. To find the interval, let the second derivative equal to 0, so we can notice that the x will become 1000. Hence, the interval are negative infinity, 1000, and 1000 infinity. So, to determine the concavity, we test the internal. The internal we put negative infinity, 1000, and the test point we put 500. So we can notice that the cost function for the second derivative will become negative 0.003, and the sign is negative. So the concavity for the second derivative cost function will become downward. And for the internal, which is 1000 infinity, and we will choose the 1500 as our test point. So we can notice that the second derivative of the cost function will become 0.03. The sign is positive, so the concavity for the second derivative cost function will become upwards. As a conclusion, the function or cost function, which is 0.00001 s cubed minus 0.003 s squared plus 5x plus 1000 is concave downwards on the intervals, which is negative infinity 1000, and is concave outward on the internal, which is 1000 infinity. So now let's look about the third question, which is question 1c. A company has attributed that the revenue function in Ringgit Malaysia is 2x cubed plus 40x squared plus 8x, and the cost function in Ringgit Malaysia is 3x cubed plus 19x squared plus 18x minus 800. So in this question, we want to find the level of production that will yield a maximum profit for the company and find the price per unit to maximize the profit. Let us look about the solution. So, want to find the level of the production that will yield a maximum profit for the company? First, we want to find the profit function. How to find the profit function? Which is profit function equal to revenue function minus cost function. So we can notice that the profit function becomes negative x cubed plus 21x squared minus 72x plus 800. Second, want to find the first derivative for the profit function. First derivative for the profit function will become negative 3x squared plus 42x minus 72. Third, to find the level of the production, which is the maximum profit, we let the first derivative profit function become 0. We can notice that negative 3x squared plus 42x minus 72 equal to 0. X will become 2 and 12. Fourth, to determine the exact unit of the quantity that maximizes the profit, we need to find the second derivative profit function. So, second derivative profit function will become negative 6x plus 42. Fifth, to note is this a maximum or minimum or an inflection? Check using second order condition, which is SOC. Second derivative profit function, which is negative 6x plus 12, when x equal to 2, the second derivative, we can notice that which is 30 and its mean more than 0. When x equal to 12, the second derivative will become negative 30 and its means less than 0. Since the second derivative profit function when x equal to 12 is less than 0, the level of the production that will maximize the point is when x equal to 12. So for the C2, we want to know the price per unit that maximizes the profit. When the level of the production is 12, price per unit, we can notice that it will become Ringgit Malaysia 102.67 cents. So the price per unit to maximize profit is 102.67 cents. That's all for me. Thank you.